Hi everyone, today's instructional objective. Students will be able to answer the question, what is the fate of our sun? Do now says, what is redshift and what can it tell us about the future of the universe? Take a moment, reflect on that, write down your answer, pause the video, and come on back now. It says, what is redshift and what can it tell us about the future of the universe? Well, when you have those spectral lines that come off of any sample of light, whether it comes from a star or a planet or whatever, if you take a look at it and you see that it shifted to the red part of the spectrum, you know that the object is moving away from you. If it's shifted to the blue part of the spectrum, that means it's moving towards you. The vast majority of stars and objects in space are moving away from us, with the exception of the stuff that's within the Milky Way galaxy. And if everything is moving away from us, that implies that the universe is expanding. Here we have a random regions question. The flowchart below shows part of the Earth's water cycle. The question marks indicate a part of the flowchart that has been deliberately left blank. We've got precipitation, runoff, goes to the ocean, something happens, and then we get water vapor. Which process should be shown in place of the question marks to best complete the flowchart? If you want, pause the video, think about it. The answer would be evaporation. Okay, so let's start off. Earth's sun. Created from a nebula, which is essentially just a cloud of gas and dust. It's what we call a main sequence star. It's a typical star. It's about 149.6 billion kilometers from Earth, and you can find that on your reference table, page 15. Sometimes we refer to this as 1 astronomical unit or 1 AU. The sun is rotating, and there is evidence for the rotation, and those are sunspots. The sun is approximately 100 times larger than Earth. So what exactly is a sunspot? It's a dark patch of cool gas on the sun. Galileo observed sunspots to show that the sun rotates every 27 days. It takes about a month. The number of sunspots vary in a cyclic manner. And that's what they look like. And what are they really? Well, all they are is just areas of cooler gas. It might only be a couple thousand degrees as opposed to 9,000 degrees. Okay, so star evolution, main sequence stars expand into red giant stars. This will be so large that it will consume the inner planets, even the Earth. Yep. So it looks like the sun will puff up to about the size of Earth's orbit, making it a red giant. Red giants eventually collapse down into white dwarf stars. And here is the simplest way to look at it. If you have a super big protostar, giant collection of gas and dust, it may turn into a blue supergiant. Now these things are very short-lived, only a couple million years, and they're eventually going to explode into what we call a supernova when they run out of fuel. If you have a protostar and it's really, really big, it may just collapse down into a black hole. If you have a protostar, it may turn into a blue supergiant and explode with a type 2 supernova, leaving a black hole behind. So it really just depends on how much mass it kicks off. If you have a protostar, it may turn into a blue supergiant, which then may puff up into a red giant. And then you really have two paths here. It can either turn into a blue giant and then go down another path, or it may blow off some gas and turn into a neutron star. Protostars may sometimes collapse into a sun-like star like ours, which will turn into a red giant, explode in a planetary nebula, and leave behind a white dwarf. And this is essentially the most important one for you to know. This is our sun's fate. Then we have protostars that may turn into red dwarfs, and the red dwarf eventually, after a very, 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 very long time, trillions of years maybe, turn into a white dwarf. And eventually the white dwarfs turn into black dwarfs, cold, dead husks of a star. And here we have protostars, which may turn into a brown dwarf. Notice we're very, very small on this scale. And the brown dwarf remains a brown dwarf. It never gets any bigger. So as a quick review, what evidence do we have of the sun's rotation? What is the fate of our sun? And what type of star is the sun? Take a moment, pause the video, try to fill in these answers. Okay, so what evidence do we have for the sun's rotation? Well, we see sunspots, and the sunspots show us the rotation rate. What is the fate of our sun? Ultimately, it will puff up as a red giant and then collapse down as a white dwarf. And what types of star is our sun? Our sun is a yellow main sequence star. Okay, couple regions questions here. 36. According to the diagram, the life cycle path followed by a star is determined by the star's initial what? 1. Mass and size. Stars like Earth most likely form directly from a nebula, supernova, red giant, black. The answer would be 1, a nebula. 38. According to the diagram, a star like Earth's sun will eventually explode in a supernova, become a black hole, change into a white dwarf, or become a neutron star. The answer is 3, change into a white dwarf. Okay, and that is it. So we do have some additional work for today. You're going to go to Lab 21, Stellar Evolution. And this is pretty easy. You're going to read through the instructions, and you're going to create basically a flow chart that shows the life of average stars and massive stars. So in this case, you see here you have a data table, or a chart at least, that shows you the information for each star type. Answer the questions by typing in the boxes. And then you have this page where, and it's kind of small, I know, it says average stars, and then it says massive stars. And you're going to move around these pieces. So if you think that, let's say, where do we have? A main sequence star is an average star. So he would be up there somewhere. Starts off with a protostar. So your protostar will lead to main sequence. We have a nebula, we have a planetary nebula. I believe we said planetary nebulas were with average stars. And this is not the correct order. I'm just showing you how to do it. You're going to go up to your line tool. You're going to select arrow, and you'll draw arrows that illustrate which direction the flow happens. All right, so there I just made the line a little bit thicker so you can see the arrow. So if that's how you think it would work, that's how we'll do it. All right, I think this is relatively simple. So this assignment, today is the 29th. You have until Monday to complete this. And that is it for today. All right, guys, I will see you soon. Bye-bye.